Hi students, today we're going to talk about dividing polynomials. So the sections are 4.7 through 4.9. So we're going to discuss dividing a polynomial by a monomial first, but we're also going to discuss dividing polynomials by binomials and trinomials, for example. So let's get started with our first example, this 6 plus 3 over 3. Well, one way that we can simplify 6 plus 3 over 3 is we can add 6 plus 3, which is 9, and divide it by 3 to get 3. But also 6 plus 3 over 3, if I am dividing everything in this numerator by 3, then this also means 6 is divided by 3. 6 is being divided by 3, as well as 3 is being divided by 3. And what is 6 divided by 3? It's 2. What is 3 divided by 3? It's 1. So we still get 3 for our answer. So notice we get the same answer of 3. Now so what was the point of that? Well, the point is if we're dividing by one number or a monomial, we can split up the numerator into different parts being divided by that same monomial. So again here, the next example, we have a dividing polynomials example, but again we're dividing by a monomial. In that case, we can divide each term in the numerator by 6x. So as long as you're dividing by a monomial, one term, you can divide 18x cubed by 6x, come back and simplify that, and divide 24x squared by 6x. All right, let's simplify this 18x cubed over 6x. Well, 6 can go into 18, of course, right? 6 divides into 18 3 times, in itself 1 time. And since we have common factors here, we have x to the third, which is x times x times x, divided by x, then we can cancel one of these x's, right? And take away one of these x's, which leaves that with 2. So already we have 3x squared plus, and over here we can simplify that as well. So notice again that we are dividing each term in the numerator by 6x, not just one term. So the mistake I normally see is someone would divide part of the numerator by 6x and leave the other part by itself, but everything in the numerator is being divided by 6x, obviously, right? Because of this line here is indicating that everything in the numerator is being divided by 6x. All right, now let's get back to it. 24 divided by 6, so that 6 goes into 24 4 times, and we can cancel out a common x, which leaves 1x in the numerator here. So that's 4x remaining. So 3x squared plus 4x. Let's move on. Notice this example as well. Notice that we are dividing by a monomial again. So we can split this up as 35x squared y cubed divided by 5x y squared minus, since this is a minus this time, minus 55x cubed y to the 4th divided by 5xy squared. So again, we can make some changes here by simplifying. So 5 goes into 35 7 times. We can cancel out an x. We can cancel out actually 2 y's here, right? We can cancel out y squared from top and bottom, leaving us with a x 7xy for that part. And then we have a minus, of course, here. And now let's simplify the second fraction. 5 goes into 55 11 times. We could take away 1x from top and bottom, so that's 11x squared. And we take out y squared from top and bottom, leaving us with a y squared at the top. So our final answer is 7xy minus 11x squared y. So in the problems above, we were divided by monomials, which it is one term. So here is a little template. As you can see, if a plus b was divided by c, one term again, you could split it up as a divided by c plus b divided by c. And of course, c cannot equal 0. That will make this undefined, obviously. So divide by binomials, trinomials. What happens when we have to divide by non-monomials, right? We use polynomial long division for that. We use polynomial long division for that. So let's go back to 5th grade when we had to divide using long division. So this example right here, y'all remember something like that from elementary school? Well, let's go through that because I want to show you that dividing polynomials is very similar to this concept of dividing 14 to 168, for example. So first thing that we do, we decide how many times does 14 go into 16. It goes in there one time. Then we multiply that 1 times that 14. So what we're doing is multiplying the divisor by what we have in the quotient. And this is the dividend. Okay, so we multiply 14 times 1 and we get 14. Don't forget, we have to subtract right here. And when we subtract, we get 2. We always bring down the next number and we start over. We decide how many times does 14 go into 28. 2 times. So we put it up here above the 8. Then we multiply 2 times 14, right? And then that's 28. Making sure we don't forget, we have to subtract and we get 0 as our remainder. Now, what does this mean? Well, it means that 12 times 14 plus 0 equals 168. Just in case you didn't know that. 14 times 12 plus 0 equals 168, for example. Now, let's go through the example of dividing polynomials. So the first thing you're going to do is you're only going to look at these first terms here. You're going to decide what times x will give you x squared. What times x is x squared? If you said x, then you are correct. Another way of looking at it is dividing x squared by x. So for example, x squared divided by x is x, correct? So that's what you're doing for the most part. You're dividing those terms throughout. So let me erase this. Let's get started. So again, x times x will give you x squared. We're going to put the x above its similar term. What I mean about that is this is x to the first power. This is 6x to the first power. So I'm going to put the x above its like term. So I wouldn't put above x squared because they're not like terms. Now what are we doing with the x? We are multiplying the x times our divisor, just like we did over here, right? Just like we did with the 14 and the 12. So we're going to multiply x times x plus 4. If you can't do that in your head, you need to write x times x plus 4 down and distribute this, right? You get x squared plus 4x. X squared plus 4x. So at some point, you should be able to do that in your head. But for now, whenever we get to a type of situation like that, write it down. What is x times x plus 4? Write it down, for example, and distribute. Don't forget, we have to do what at this point? We said we had to subtract on the left side over here, right? We have to subtract. And that's what we're doing. But if we have to subtract more than one term, then that means we have to distribute that negative, right? So if I had this, wouldn't I have to distribute all that negative through? So actually this becomes a minus, and this also becomes a minus sign when you distribute that negative through. Notice that x squared minus x squared cancels. It should. If it doesn't cancel, that's a problem, and you may need to start over. And next, 6x minus 4x is 2x. And we bring down a term now since we are dealing with polynomials. We start over at this point. X. This x times what will give us 2x? X times what will give us 2x? It would be a positive 2. Now we multiply the 2 times the divisor, which is 2x plus 8. Don't forget, we have to subtract, which means we're changing the signs, and we get a 0 remainder. So what does it mean? It means that x plus 4 times x plus 2. So this times this plus our remainder will equals our dividend, x squared plus 6x plus 8. And you can always test that out by FOILing this information. All right, let's move on. And I have a note. Note the similarities between regular long division and polynomial long division. They are very similar. To make it easier on you in this section, I recommend that you use a pen or colored pencil when changing signs. So notice in these following examples, I've changed up the instructions, but notice that it's all division, right? A is actually says divide, but B has a symbol for division as well. I wanted to switch that up so you would know that you can use the same method to divide polynomials. So the first thing that we need to do when we're dividing polynomials is to ensure that we have all of our terms and that our polynomials are in descending order. And what I mean about descending order is from greatest to least. So ensure that your powers are from greatest to least. Also ensure that all terms are represented. So for example, if you start with a 5x squared, then we need an x term and we need a constant. For example, if you start with x to the first in your divisor, you need a constant right after that. And everything looks pretty good. Everything's in descending order because we have a power of 2 first, then a power of 1. And what is the power for 8? The power is 0 because it's 8 x to the 0 power, for example. So let's set this up as long division. It will be x plus 2 divided into 5x squared plus 6x minus 8. Again, we start with the x and the 5x squared here. We decide what times x is 5x squared. And again, you could also look at it as 5x squared divided by x equals what? Okay, those are the things you have to think about. So if you said 5x, you are correct. We're going to put it above its like term. And here it is 6x. We multiply 5x times x plus 2. And we get 5x squared plus 10x. And then we subtract. So let me subtract. We're going to have minus here and a minus here. And then that cancels as it should. We have negative 4x, since 6 minus 10 is negative 4. And we bring down our next term. And we start over. All right. We always start over. Unless this variable is lower than this variable over here. Okay, so we always continue. And also notice your answer is going to go in descending order. If we have 5x in our quotient, then we know there should be a constant next. Okay, so x times what is negative 4x. X times what is negative 4x. If you said negative 4, you are right. Then we multiply negative 4 times x plus 2. So that's negative 4x minus 8. Then we are going to change our sign. So notice this is a little different. Now we started with a negative. If negative times negative, we be positive. So we change these signs to the opposite signs. Because if we subtract a negative 4x minus 8 and distribute that, we would get positive 4x plus 8. So that's why we change our answer to plus 4x plus 8, which gives us a 0 remainder. So our answer is 5x minus 4. All right, when your remainder is 0, there's no need to write your answer in a certain way. And we're going to get to some examples in a few minutes where we will have to write it in a certain format because we have a remainder. Let's set up B. All right, what do you notice that's different about B? Well, you should notice that this is not in descending order. Okay, so when we start to write 4x, let me put it over here, 4x minus 1 divided into, we need to put 12x squared first, minus 23x, because notice there's a minus sign in front of the 23x. So we always carry the sign that's in front of that term with it. And we have plus 5. So 4x times what is 12x squared? So if you said 3x, you are right, absolutely right. So 4x minus 1 times 3x. If you multiply 3x times 4x minus 1, you get 12x squared minus 3x. And it'll be a good thing to pause the video before I actually do the next step to ensure that you understand the material, because it seems easy when you see me doing it, but you need to practice as much as possible so that this becomes second nature to you. So if you don't look at it every day, this is not going to stick. So you need to look at it every day. Look at this every day. If you want to pass this class and you know you have not done well in math in the past, you have to spend more time than someone else who may like math or who had an excellent teacher in math. So they were pretty much forced to learn every concept. So you may have to spend make up for that by spending more time with the math. All right, now we're going to do what? Well, we should change our signs here. And then that cancels. We have negative 20x plus 5 now. 4x times what is negative 20x? 4x times what is negative 20x? Negative 5. So negative 5 times 4x is negative 20x plus 5. And then you change your signs. And you get 0 remainder for that one. Now notice for this problem, see that I have a little message over here. There's a special way to write this one, and that special way is quotient plus remainder divided by divisor, and I explain that after we work on this one. Alright, so let's set this up as x minus 8. Notice we have all of our terms. They are in descending order, so we're going to get started right away. So x times what is x squared? It is x, and then we multiply x times x minus 8, which is x squared minus 8x. Now we're going to change our signs to minus plus, and then that cancels. We have negative 2x plus 15. X times what is negative 2x minus 2. Negative 2 times x minus 8 is negative 2x plus 16. And then we're going to change our signs again, plus, and this becomes a minus sign now. And then we have a remainder of negative 1. So how do we write this? Well, we're going to write it as quotient plus remainder over divisor. So this x minus 2 part is our quotient. Plus, so notice this plus here, plus we're going to put remainder negative 1 over our divisor, which is x minus 8. Okay, so this is how you're supposed to write the answer. All right, an alternative way to write it would be x minus 2. Since a positive times a negative here is negative, the negative dominates, right? The negative dominates. You could just write minus 1 over x minus 8. So this is also an alternative way to write this right here. So either or will work for me. All right, let's go to the next problem. I'm going to erase some of this so that we can have a little room here. So let's begin. Make sure that you have all your terms. We do is in descending order, 3, 2, 1, and then we have a constant. So let's begin. Even in our divisor, you always have to check to make sure you have all your terms in your divisor as well. Since we start with x to the first, we have a constant, so we are okay there. So x times what is 6x cubed? 6x squared. And where would you put the 6x squared? All right, if you said above the negative 2x squared, then you were right. Then we're going to multiply 6x squared times the divisor, which gives us 6x cubed plus 6x squared. Then we're going to change our signs, minus, minus. So now we have negative 8x squared, and we're going to bring down 4x. X times what is negative 8x squared? It is negative 8x. So we put our negative 8x there, and then we're going to multiply negative 8x times x plus 1, which is negative 8x squared minus 8x. Then we're going to change the signs, plus, plus. That cancels here, but we have 4x plus 8x, which is 12x, and we bring down minus 3 and start over. X times what is 12x? Positive 12. And positive 12 times x plus 1 is 12x plus 12. But don't forget, you have to change those signs. So that cancels, but we have negative 3 minus 12, which is negative 15. So how do we write this? How do we write it? Well, again, this is our quotient. We put plus negative 15 over x plus 1. All right, something's different about this one. Can you figure out what it is? For E, what is different? Well, notice that we are missing some terms here. So something's missing in between these terms. That's your hint. So notice we don't have all of the powers here. So we have 2x to the 4. But we're missing x to the third. So we're going to replace it with 0x to the third. We have 3x squared, but we're missing x. So we'll put 0x plus 3. We can't simply put x because that means 1x. And obviously there's no 1x. 0x is 0 times x, which is really 0. So we can't alter the problem in such a way that it changes the actual polynomial. It must be equivalent in math. Everything has to be equivalent, or else you just changed the problem, and obviously you'll change the solution. So this is how we're going to set it up. So we have x plus 2 divided into what? What are we going to write for our dividend? 2x to the 4th, which is fine, right? But now we have 0x cubed. We already have 3x squared, but we are missing a 0x, and we have the plus 3. So let's begin. X times what is 2x to the 4? It's 2x cubed. We're going to multiply that times x plus 2 to give us 2x to the 4 plus 4x cubed. And then we're going to change our signs again. So our signs should be minus here. That cancels. We have negative 4x cubed because of 0 minus 4. 0 minus 4 is negative 4. We're going to bring down one term at a time and start over. X times what is negative 4x cubed is negative 4x to the second. So negative 4x cubed minus 8x squared. Change our signs. That cancel. We have 11x squared plus 0x. Start over. X times what is 11x squared? That's 11x. Now notice, y'all see how this is going down in descending order? As it should. 11x times x plus 2. 11x squared plus 22x. Change the signs. Minus minus. That is a negative 22x. And we're going to bring down that plus 3. Start over. X times what is negative 22x? Negative 22, which would give us negative 22x minus 44. And then we change the signs. to give us a remainder of 47. So we have our quotient here. We're going to put plus because our 47 is positive. 47 over x plus 2 is our answer. All right, let's go ahead and go to the next one. So it looks like my automatic ordering is not working because that was E. So this should be F right here. So we have 5x cubed plus 2x minus 3 over x minus 2. So I'm going to put that over here. We have x minus 2 divided into, do we have everything we need for this problem? So it looks like we're missing something because I should have an x squared term. So what are we going to replace that with? So if you said 0x squared, you are correct. So again, you can't just say x squared because that means 1x squared, which will alter the whole problem. You must say 0x squared because there really isn't a x squared term. So these are just placeholders. We call them placeholders. All right, is holding that spot for a second until we get the answer. All right, and then we're going to write in our 2x minus 3. X times what is 5x cubed is 5x squared. And we're going to multiply that to get 5x cubed minus 10x squared. Then we're going to change our signs, so minus plus. So we have 10x squared plus 2x. X times what is 10x squared? It is 10x. 10x times x minus 2 is 10x squared minus 20x. And then we change the signs. Minus plus. We have 22x. And we bring down the next term minus 3. X times what is 22x? 22. And we multiply 22 times x minus 2, which is 22x minus 44. Don't forget to change your signs. Negative 3 plus 44 is 41. So we will write it as plus 41 over x minus 2. All right, let's move on to this problem. T cubed minus 8 over t minus 2. We'll set it up as t minus 2 divided into what? So what terms are we missing? We're missing 0t squared and 0t. So we're going to write it in. T cubed plus 0t squared plus 0t minus 8. Start with t and t cubed. What times t is t cubed? If you said t squared, you are correct. T squared times t minus 2 is t cubed minus 2t squared. And we're going to change our signs. So this becomes minus and this becomes a plus. Now we have 2t squared. We're going to bring down one term, 0t. And start over. T times what is 2t squared? 2t. 2t times t minus 2 is 2t squared minus 4t. And we're going to change our signs. Minus plus. We have 4t and we bring down the next term, negative 8. And we start over. T times what is 4t? Positive 4. 4 times t minus 2 is 4t minus 8. Change the signs. And you get a 0 remainder. So your answer is t squared plus 2t plus 4. Let's move on to the next one. Divide y cubed plus 3y squared minus 2y minus 1 by y squared plus 2y. What I want you to notice in this one is that even in the divisor, we are missing something. We're missing a constant term. So let's put plus 0 here. So when we write it out as long division, we will write a plus 0 in the divisor to represent the constant. We have everything we need in the dividend. So y squared times what is y cubed? Y. So y times y squared plus 2y plus 0 is y cubed plus 2y squared. And obviously 0 times y is 0, but we're going to write 0y. All right, and then we're going to change our signs. Y cubed minus y cubed cancels, but we have a y squared remaining and a negative 2y. And we're going to bring down one term and start over. Y squared times what is y squared? Positive 1. So we have y squared plus 2y plus 0, but don't forget you must change your signs. So that cancels, and our remainder is negative 4y minus 1. So here we'll put a plus sign, negative 4y minus 1 over y squared plus 2y. It's unnecessary to put the placeholder there once you have the answer. All right, now let's talk about synthetic division, which is an easier way to divide polynomials. When can you use synthetic division? Well, if your divisor is of the form x minus k, then you can use it, which means that your leading coefficient has to be 1 in the divisor, and that's pretty much it. If your leading coefficient in your divisor is 1, then you can use synthetic division. For example, x plus 4 divided into x squared plus 6x plus 8. We can use synthetic division on this because this is a 1x to the first power. So as long as your leading coefficient of the x term is 1 in the divisor, you can use it. And here's what you need to do. The first thing you're going to do for synthetic is you're going to figure out what your k is in the divisor. So that's a little tricky because it's always opposite of what you see. So if this is positive 4, then your k is actually negative 4. That's usually the easiest way to figure out what k is, because the template is x minus a negative k. So our k must be a negative 4 for that to work. For example, x minus a negative 4 will give us our current divisor. So we're going to write our k in this little box here, like so. And we're going to write the coefficients of our dividend right next to it. So the coefficient of x squared is 1. The coefficient of 6x is 6. And then we have our constant. So synthetic division is a little simpler because we're only dealing with numbers and not variables. The first thing you do, you're going to drop that first number here. That is 1. Whatever you drop below the line, you're going to multiply it times what is in the box. So 1 times negative 4 is negative 4, and you're going to put it under the next number. Now, what are you doing with the columns? You are adding. You add. So 6 plus a negative 4 is 2. Then you multiply what you put under that line times the number in the box, which is -8. And then again, you add. 8 plus a -8 is 0. That last number represents your remainder. Now, we've done this problem before in the beginning of the lesson. If you go back to the beginning of your notes, you know the answer. Now, our answer lives in this part right here because our remainder is 0. And we don't have to deal with the remainder once it's 0. Since our answer lives in here, I'm going to show you how to get the answer from these two numbers. Now, our dividend, notice our polynomial was x squared, and we're dividing that x squared by x, right? So if we're dividing that by x, our first variable should be x, and this number is the coefficient of it, all right? So it's always, your answer will always be one number lower than degree less than 2. So that would be 1. And of course, after x to the first power, you always have a constant. So that's why we'll just put a plus sign, plus 2. No need to write a variable with that since we know it's a constant. So our answer is x plus 2. Now, if you go back to the beginning of the lesson, you'll see that we already worked that problem out, but we used long division instead of synthetic division. Let's try another one. This is another problem that we've done before. We're dividing by x plus 2. So what is our k in this case? It would be -2. And then we have all our terms here. So we'll write 5, 6, and -8, only the numbers. We always drop this number. So that'll be 5. We multiply this times this. That's -10. We add the columns. So that'll be -4. Again, we're going to multiply -4 times what's in the box. That's going to give us a +8. And notice that again, our remainder is 0. Since we had 5x squared, so 1 degree less than that would be 5x. And you can extend this negative to make it a minus sign. So the answer is 5x minus 4. Moving on. Let's try t cubed minus 8 over t minus 2. What is our k in this case? Well, it's opposite of what you see here. So it would be a +2. But notice we're missing some terms, right? We're missing the 0t squared and the 0t. So when we write down the coefficients, we should put 1 for t cubed, 0 for 0t squared, 0 for 0t, and -8. Again, what is the first step of this process? We always drop whatever that number is down. We multiply 1 times what's in the box, we get 2. We add, we get 2. We multiply, we get 4. We add, we get 4. We multiply, we get 8. And we add, we get 0. So our remainder again is 0. So no need to worry about the remainder or how to write it in a special way because our remainder is 0. Now, since we were dealing with t cubed originally, then 1 is the coefficient of what? If you said t squared, you are correct. And then we're going to go down in descending order. So that's t squared plus 2t plus 4. So that's t squared plus 2t plus 4 as your final answer for that one. All right, here are some extra problems. It says divide by using long or synthetic division. You have to know when you can use synthetic division, however. Long division you can use in any situation, but you can't use synthetic division on any situation. So we have, for example, this first example, we cannot use synthetic division because we have a leading coefficient of 2. And in order to use synthetic division, our leading coefficient has to be 1. So we're going to have to use long division. So we're going to write 2x minus 7 divided into 12x squared minus 32x minus 35. Make sure you have all your terms represented and your polynomial is in descending order. So we have 2x times what is 12x squared? 6x, and 6x times that would be 12x squared minus 42x. Change your signs, you will get 10x, bring down the next term and start over. 2x times what is 10x? 5. 5 times 2x minus 7 is 10x minus 35. And when you change your signs, you do not have a remainder. So your answer is 6x plus 5. And again, the reason why we couldn't use synthetic division is because our leading coefficient of the x term is not 1 in the divisor. Alright, let's go to the next problem. Do you think you can use synthetic division for this problem? Yes, you can. And what is k in this situation? K is positive 1. But when you look at this polynomial here, do you notice anything that's missing? Yes. You're missing an x squared term, so you need to replace it with 0x squared. So what are our coefficients? They are 4, negative 2, 0, 6, and negative 1. So we're going to drop 4, multiply 4, add 2, multiply again, 2, add 2, multiply 2, add 8, multiply 8, add to get 7. And our answer would be 4 what? Since we started with the 4th power, we will have 4x cubed, because it's always going to be 1 degree lower. So 4x cubed, and we go down in descending order, plus 2x squared, plus 2x, plus 8, plus 7 over x minus 1. Alright, and the reason we could do synthetic division is because that is a 1x to the 1st power. So as long as that leading coefficient is 1 and that power is 1, that degree of the divisor is 1, you can use synthetic division.